Okay, well, let's prove this theorem. Let p be a prime number, and suppose a is an integer. We're going to show that if p divides a, then p does not divide a plus 1. Proof. We're going to do this by contradiction. So suppose, for the sake of contradiction, in non-mathematical terms, suppose for the sake of argument that we assume the hypothesis that p divides a, and we also assume the negation of the conclusion. The negation of the conclusion is that p divides a plus 1. Now, when I read this, a plus 1 is in parentheses. By definition, there are integers, j and k, so that, okay, if p divides a, that means that a is equal to p times j for some integer j. And if p divides a plus 1, that means that a plus 1 is equal to p times k for some integer k. So substituting, we obtain that p times j plus 1 is equal to p times k, or that 1 is equal to p times k minus p times j, or that 1 is equal to p times k minus j. Okay, now why is this bad? By the axioms of arithmetic, k minus j is an integer. Therefore, p divides 1 by definition of divides. Well, the only numbers that divide 1 are 1 or negative 1, so p equals 1 or p equals negative 1. But that can't happen, but p is prime. And so p does not equal 1, and p does not equal negative 1 by definition. So for the sake of contradiction, let's assume the negation, the hypothesis and the negation of the conclusion. We run through the argument, and I show that something is both true and false at the same time. P is 1 or p is equal to negative 1, but the negation of this conclusion is also correct, that p is not equal to 1 and p is not equal to negative 1. So there's my contradiction. So therefore, we conclude that p does not divide a plus 1. And that's the end of the proof.